Hello friends, welcome to the next lecture on differentiation of implicit functions. In the previous lecture we saw how to differentiate a function of a function. That is, within a root function you had an additional function. So in this lecture we are going to see how to differentiate implicit functions. First let's look at what are implicit functions. So just open your textbook exercise 8a and come to question number 12. So in this implicit function series, we are going to do question number 12, 13, 14 and 15. These are the 4 questions we are going to do. Now look at all the 4 questions. So far, whatever questions you did, you always had the question as being y is equal to a function of x. You had f of x is equal to a x function. Now look at this question. This is the first time you're having a question where you have e power minus xy. X and y are coming together as one term. Okay. Now minus 4xy. So this is an implicit function. Now look at this question. Again in this question you have x and y together on the same side. Now look at this. X divided by y. Now look at this, x cube, y cube and axy. Again x and y together. So all the 4 questions we notice that there is a similarity. So these are the type of questions which are called as implicit functions. Now whereas if you look at some other question, like the question number, see, question number 10 is also an implicit function. However, it's a very straightforward, simple question after we do these questions. So I will be giving that to you as your self-practice. Now, this is an implicit function. Whereas, look at this question. There is only an x on the side where you have to differentiate. On the other side, you have y is equal to. Similarly, you can look at any other question. Let's say, look at question number 18. Y is equal to 1 by root x. This is not an implicit function. This is a regular function. Okay. So that's why I gave you question number 18 as your homework in the differentiation of a function. Very straightforward question. Now let's come back to implicit functions. Let's start with the 12th one. Okay. I've already taken down the question here. E power minus xy minus 4xy is equal to 0. Now let me just go back and revise our product rule. When you had a function u into v and you had to differentiate this function, that is, you had to find d by dx of this. Okay, what did we do? uv dash plus vu dash, correct? Now in this case we have xy as the function. This is your u and let's say this is your v. Okay, so we are finding the d by dx of this particular function. How do we do this? u v dash is y. Differentiation of y is dy by dx. If it is difficult for you to visualize, let me write here. X is your u function, y is your v function. So u dash is nothing but 1, v dash is nothing but differentiation of y, which is dy by dx. So u v dash plus v u dash, which is 1. So y into 1. So this is the value we get for xy differentiation. Okay. So now let me differentiate this. E power minus xy. E power minus xy is nothing but e power minus xy as it is multiplied by, there is already an inherent minus here. So that minus we will put here and differentiation of only the xy term within brackets. What is that? X dy by dx plus y. Okay, minus 4 coefficient, write it as it is, and within bracket only the differentiation of xy, which is x dy by dx plus y. Okay, Now look at this term and look at this term. Is it not the same? So we will take this out common. Now before we take that out common, let's write here 0 on the right hand side. We need to write that. Okay, next. X dy by dx plus y, you write it as it is. Close the bracket. Then put another bracket. Write down the remaining terms, which is this term minus e power minus xy minus 4 is equal to 0. This equal to 0 is a very useful thing for us. You know why? In the next step, we'll be taking this to the other side. Then it becomes a 0. It vanishes along with the 0, because on the other side it becomes 0 divided by this term, and therefore this term becomes 0. So what you will be left with is only x dy by dx is equal to y. So therefore in the next step, dy by dx is nothing but, not equal to y but a minus y, because this y comes to the other side, it becomes negative. So minus y divided by x, this coefficient x comes to the denominator. So your answer is nothing but option, which option is this? Minus y by x is option A. So let's write that down, option A. Okay. Now friends, probably this is the only chapter where we have worked out so much and then wrote the answers. All the chapters that we did together in the previous the previous permutation combination, we had done a lot of shortcuts, a lot of methods where we found the answer without using a pen and a paper also, especially in permutation and combination. And in the annuities chapter, we have been able to find our correct option by just option elimination or using the calculator shortcuts. So probably you'll have to bear in mind that this is the only chapter where you may have to do this kind of workout. There is no other choice. In differentiation and integration, both the chapters where it is pure mathematics, that's how it is. Okay, now let's go to question number 13. I have written down the question number 13 here. Now let's just refer here. This is the question. Question will always ask you for dy by dx here, and look at the options. There's a root of x square and a square and all that. Let's see what answer we get. Okay, I told you this is an implicit function, correct? So in the next step, what we are going to do is x square minus y square, I'm going to take LCM because both have the same denominator. This is equal to 1. In the next step, x square minus y square is equal to, I'm going to take the a square to the right hand side. So 1 multiplied by a square is nothing but a square. Now at this stage, I'm going to say differentiating both sides. When I differentiate both sides, differentiate each and every term slowly and patiently. First, the x square term. X square differentiation is 2x. Y square differentiation is again 2y. Okay, the minus as it is we have to put. Now remember, whenever we differentiate the y term, it will always be accompanied by an additional dy by dx. Now this is equal to differentiation of a square is nothing but 0. Okay. So next step, let us write down 2x is equal to, take this term to the right hand side, 2y dy by dx. Now cancel the 2 on both sides. The question was asking us to find the value of dy by dx, so isolate it to the right hand side. Okay, is equal to, x is already there, bring the coefficient down, becomes x by y. This I remember is option A, correct? Let's go back and check whether we are right about this. So option A is your answer. Now let's go to question number 14. I've already taken down the question here. The question again is asking you to find the value of dy by dx is equal to question mark. Now here I am going to use a property of logarithms which says log of m divided by n is nothing but log m minus log n. Remember, it is log of m minus log of n, not loosely log m minus n. Okay, fine. Let us use that now. Log x minus log y. Please remember, students, as soon as we see the question, we don't start differentiating. We first try to use some property by which we can simplify it. For example, here we use the logarithm property and we simplified it. This is equal to x plus y. Now is where we are going to differentiate. So write down differentiating both sides. Now differentiating both sides. Log x differentiation is 1 by x. Log y is just the same, 1 by y. Whenever we differentiate y, we always write dy by dx. Additionally, equal to x differentiation is 1, y differentiation is 1. Whenever we differentiate y, we write dy by dx additionally. Okay, so this is what we have. Now combine the dy by dx terms together, the other terms on the other side. So 1 by x minus 1 is equal to 1 by y dy by dx plus dy by dx. Now take LCM here. It is 1 minus x divided by x is equal to dy by dx, you take out common. What will remain within bracket is 1 plus y divided by y. Okay, students, I have just taken the LCM here. If you want, I can show you the additional step here. Dy by dx, when I take out common, I will get 1 by y plus 1. This is nothing but the next step, whatever we have written here. Okay, the next step is for us to find dy by dx value, which is nothing but 1 minus x, you write as it is. This y will come here on top. Okay, denominator already there is a x. What will come additionally is 1 plus y. Now let us look at the options for question number 14. So it matches ditto with our option A. Answer is your option A. Now let's move on to question number 15. Question number 15 is nothing but again a parametric function. Question is expecting you to find dy by dx. Okay, so remember x cube, y cube, 3axy, all the three terms. Let us differentiate as though three separate questions. X cube differentiation is 3x square. Y cube is 3y square, same thing, into dy by dx. Whenever you differentiate y, you have to multiply it with dy by dx. Okay, minus 3 and a are constants. Write the two terms as it is and then differentiate xy. How do you differentiate xy? We just saw, right, in the previous questions. Let me show here on top. We differentiated xy here. Can you see this working? This is the working. Okay, in this working, what was our conclusion? Differentiation of xy is nothing but x dy by dx plus y. Okay, x dy by dx plus y. So we'll use this conclusion here. In fact, in your examinations, it will be very useful for you to remember this result, because when you have a long question like this, you can just use it rather than again working it out. Equal to 0 on the other side. Now I can see that there is a 3 common in all the three terms. I'm going to take the 3 out common. So it becomes x square plus y square dy by dx, and here I'm going to expand it. Okay, when I expand it, I will get ax dy by dx minus ay. This is equal to 0. So the question is asking us to find the value of dy by dx. So let us keep both the dy by dx terms separately. Sorry, I missed the d here. Dy by dx, if I keep it separately, what I get is y square minus ax, close the bracket. On the other side, this term comes here, it becomes positive, minus x square. So in the next step, dy by dx will be equal to ay minus x square divided by y square minus ax. Okay, this is nothing but which option? Let us check that. Ay minus x square is there in both the options, but the denominator also has a negative here, not here. So we'll pick up option B. Now as a follow-up, you can do question number 10 and question number 26. So in the next video, we'll be seeing how to differentiate parametric functions, and then we will proceed to logarithmic differentiation and slope of the curve differentiation in the subsequent videos. Thank you, good luck, and keep practicing because in each video we are taking the next concept. So unless you practice these concepts again and again, you will have a difficulty in practicing the understanding the next concept. So practicing is very, very essential. Thank you.